Hi guys, let me take a few minutes and look at the solutions here with you regarding the review of experimental design that we were working on today. So in this unit we've studied observational studies and experiments. This is an experiment because we have random assignment to a treatment. So some of the subjects were randomly assigned to do 2 minutes of relaxing or quiet breathing before they took this quiz over factoring, and the control group didn't do that before they took the quiz. But that assignment was random. So randomness is an important part of experimental design. So is replication. You can think of replication like repeating. So replication is satisfied because we have 42 students that participated. So we're repeating this on many students. Randomization is an important characteristic of a well-designed experiment. So is replication. And the other characteristic of a well-designed experiment is control. So the most important way in which we have a control in an experiment is when we have a specific basis for comparison. So this is the design of this experiment. So we have 42 probability and statistics students. It's important that you explicitly say that you're randomly assigning them into two groups. So we have split them evenly, 21 into the group that involves relaxing or quiet breathing before they do this quiz, and the other 21 then are ending up in the control group. So it's also important that you describe the comparison that you're going to make. So we're going to look at the proportion of students that got at least one question right in the quiet breathing or the relaxation group compared to the control group. So we want to compare the proportion that get at least one question correct in both groups. But ultimately, we're not just comparing these groups to one another. We're going to look at the difference that we see between these two groups. And we're going to compare, is that difference special or unique or significant compared to what would happen by random chance alone. So if you're at least writing about a comparison here, you're writing in context, so you're talking about making a comparison between how many get at least one question correct between the two groups, between the treatment and the control group, then you understand that comparison is important. But really, ultimately, what we're going to compare to is what we would see happen by random chance alone. So that's why we have a simulation on the second page of this handout, so that we have a basis for comparison. So looking at the actual sample results, 17 out of 21. So this is in the treatment group. 81% in the treatment group got at least one question correct. In the control group, where they did not relax before they took the quiz, 15 out of 21, or 71%, got at least one question correct. So that's a 10% difference. So does that 10% difference suggest that quiet breathing or relaxing makes it more likely that you will get at least one factoring question correct? So more likely by 10%? Or is that 10% something that we're seeing just by random chance alone? And that's the idea of the second page. So take a look. This is a simulated group of differences between the proportion of the relaxation group, the treatment group, versus the control group. The difference between those two proportions that got at least one question right. Now, notice 81% in the treatment group got a question correct, at least one question correct. 71% in the control group got at least one question correct. So when we did this simulation, I assumed that 76% is the truth. So in between those two percentages, halfway between 71 and 81% is the 76%. So if we assume both groups have a 76% chance of getting at least one question correct, then what we're saying is that there's no difference between the treatment and the control group. They each have the same success rate. So again, notice it isn't a surprise then in the simulation if you look at a difference of 0. 0 is in the center of our simulation, and that shouldn't be a surprise because we're assuming in both groups, the treatment group and the control group, the success rate is 76%. So sometimes, just by random chance alone, the treatment group will have an unusually large percentage that get at least one correct compared to the control group. Here we saw a 38% difference just by random chance alone. Here, twice we saw a difference of negative 34%. So the control group had 34% higher getting at least one question correct than the treatment group. So by random chance alone, you can get variability. That's what we see here in this graph. But we're going to use this graph, this graph assumes that the differences we see are by random chance alone, and we're going to compare our 10% to that. So from number 5 on the front, the difference between the proportion of students in the relaxation group versus the control group that got at least one question correct is approximately 10%. So if we assume that the true difference, so the real difference between the proportions is 0, so that's what this simulation is doing. If we assume that both groups have a 76% success rate, then the real difference is 0. 76% in the treatment group, 76% success in the control group. The true difference is 0. So you could say, assuming that the true difference or the real difference between the populations is 0, the simulation above suggests, so this is a simulation, that the likelihood, I suppose you could say probability here, the chance of a sample result as or more extreme than our 10%. So how often do we see a 10% difference or higher between the treatment and the control group just by random chance alone? So here are the 10%. So literally what I want to look at, I want to count up all of these observations. 8 here, 8 more here, 8 here, 7 here, 4, 1, and 1. So if you add the 8, the 7, the 4, the 1, and the 1, you get 29 simulations. Out of the 100 simulations, 29 of the simulations had a success rate of at least 10%. Here we had a success rate of 14%. 7 had a success rate of 18%. So how likely is something like our 10% or even more extreme than that? Well, it happens 29 out of 100 times in our simulation. That's 29%. So as we've talked about in class, 29% is relatively likely. That's close to a third. That's close to suggesting that 1 out of every 3 times we do this experiment, just by random chance alone, we'll see something as high or higher than 10%. So since this is relatively likely to happen just by random chance alone, we do not have a statistically significant result. So that phrase is important. We use the word significant very casually when we think that, in our own opinion, something is significant. But if we believe that something is statistically significant, that means that we believe we have evidence that what we are observing is happening by something other than random chance. In this case, we really can't say that. Our result or something larger than our result will happen almost 30% of the time, just by random chance. So our result that we saw in our experiment of 10% is not a statistically significant result. So what we're saying, in other words, we do not have evidence against the assumption that the real difference is 0 between the proportion of students that got at least one factoring question correct, so that's the context, in the relaxation and the control group. So again, our simulation assumes that the difference is 0 between those two groups, and our sample result of 10% is actually pretty likely in the context of this simulation. So we have no reason to doubt. We have no reason to doubt the assumption made by the simulation. We don't have evidence against that assumption that the real difference is 0 between the percentage in the treatment and control groups that get at least one factoring question correct. So now we can't prove it. Statistical analysis of an experiment can't give us proof. It can simply give us evidence of a conclusion. So that's why I wrote this. The difference may really be 0 in the general population of students. So remember, we don't know what would really be true if we did this experiment on all students. We're trying to infer what might happen for students in general. We've assumed in the simulation that for students in general the difference is 0, but even though we don't have a statistically significant result, we still can't say that the difference is 0 in the general population. It might be 0. We have no evidence to believe that it isn't anything but 0 because our result wasn't statistically significant. So our 10% result, even though 10% more in the treatment group than the control group were able to get at least one question correct on the factoring quiz, The truth is that 10% just isn't large enough or extreme enough to believe that it happened by anything except random chance alone.